with, I'm going to dress the wheel, and I'm going to go through sharpening. Hey guys!
Yes!
I'm going to dress the wheel first, and then I'm going to go through sharpening the slipper blade, every aspect of it, and that's going to bring to mind things to me that I want to point out. Don't be afraid to ask a question, right? That's going to give me more topics to go through. So let's just start by dressing the plate. I know that there are a whole lot of different solvents out there. I use H42, it's pretty expensive. You can water this stuff down with a little bit of, what is it, mineral spirits, and it works the same. But this stuff smells good too. It smells like kind of like baby.
If you got a plate that's been heavily used and not properly cleaned down, I would recommend a full wash, dish soap and everything.
If it's that bad, I'd send it back in and have it resurfaced. But
I mean, like, it's, you know, it's just, it wasn't properly
clean, yeah, of course. Just H42 is a solvent, so it's going to take anything grease-wise off there. It's going to take everything off eventually. It's just got
So
to.
you wouldn't need to take it out and dish soap it down?
Yeah.
Okay.
I mean, you can, but as long as you get that upper surface clean, look at the rest of this machine, it's nasty. It doesn't matter.
Because, yeah, my wheel is definitely.
All right, then we're going to put a little bit of that, I don't have a trash can over here, do I?
Right here. Right by John.
I'm using just straight lard oil, Oster lard oil. There's a bunch of stuff out there. I mean, coconut oil. I've heard of guys using W40. I like something that's got a little bit more viscosity to it because this is your bonding agent to the plate, right? So something that's a little bit thicker, I feel like it's going to hold the grit a little bit better. Some guys use a quarter. I just make a little squiggly all the way around this thing. You know. And they're going to wipe that in with a blue towel. I should put more oil in there, huh? So we're good. And what we do when we do the oil situation is I don't want to see any oil. I just want kind of a sheen on top of the plate when I get done. Just a little shiny. No liquid. And the way I know that I've done that when I go back and I put my grit on, I guess Mitch has got that really cool grit machine that puts it down the width of the, yeah, I do that, but I just do it by, right.
What size grit are you using?
What kind of what? This is 180 grit. I use 180 on everything, man. I'll go down to a 220 or a 240 if I'm going to be doing a cutter on a 5-in-1, but it's not necessary because I'm not using the whole plate. So I'm doing a 5-in-1 cutter. I'm just on the outside and I'll touch down. Dennis came up with this amount of pressure. The amount of pressure that you think would be comfortable if you close your eyelid and you touch your eyeball, that's about the amount of pressure you want to use on a 5-in-1 cutter. That's what I use on everything, actually. The pressure that I'm pushing down with is just enough to keep that blade flush. That's all I'm doing. And the more pressure that you use, the easier it is to keep it flush, right? But the main thing is keeping it flush. You know what I mean?
How much grip? That's an 18-inch.
This is a 16-inch plate.
How much grip do you use on a 16-inch?
Just I want to do a little nice covering. You know what I mean? A lot of guys are doing like a dot of oil and wiping that the whole plate and then doing just a little bit of grit and trying to get that. I want an even coverage. Grit cheap, and so is the bonding agent.
Way
right?
more than resurfacing.
Yeah, way cheap. So I mean, it's not a waste. I'm using a piece of a clipboard. Cut them up. They're pretty stiff. It's a fiber board with a little bit of grip tape on the back. I know a lot of guys are using a wooden block that's machined flat and this and that and the other. And it really doesn't matter. You're not changing the shape of the wheel. You're just getting the grit down into the wheel. I like to have a little bit of flex so that I know that I can push my fingers into my palm and whatnot and really get the grit down. I'm gonna make 2 passes. I'm gonna push all the way around and I'm pushing really hard. I'm making a circular pattern and I'm gonna get out to the outside. And when I get done, I want a nice, like grayish color to the whole plate, and I want it even. And if you've got it too wet, it's going to start doing this. As you're going through, you'll see it start to get really dark and leave little spots. You want to go over that area again. You want the whole thing to be gray, just the same color, monochromatic gray all the way around. See it starting how it's doing that out there? I don't want that by the end of the deal here, but I'll cover it. It's because I left it a little bit wet when I put the oil on there. I mean, sliding up off. All right, now we're coming in. All right, that is the first step of bedding the grit in. All right, we're gonna turn the machine on. The low speed on this machine is gonna be about 30 hertz. I don't even know what the RPM is on the high speed, the plate RPM, I don't know. I think it's somewhere about, Ray, where are you at? 1700? About 1,700 full speed on a Nebraska?
1725.
Okay, all right, so that's half of that at 30 hertz. And then we're going to properly bed the grit. To do that, we're going to use a comb that we don't care about because it's going to screw it up. And the reason why that is if you'll watch when I first set this blade down, you're not going to be able to see the spark pattern as well in here. But when I first set this down, all the spark's going to be on this side of it. And as it's pushing that rolling grit off, as I'm pushing it out, it'll bring my spark pattern in. So I'm going to start on the inside of the plate, and it's going to push it on out until I've got a nice, even. All right, I see spark coming from every portion of the blade there. We know that the plate is ready to rock and roll. And we're going to bring her on up to speed. And it's time to do some sharpening. All right, so let's move on, and we'll take a blade apart. And I want to address some things here as we're taking a blade apart. Just like you do an analysis on a shear as you're pulling it apart, looking at that ride line, looking at that, looking at this, that, and the other. By the time I get ready to assemble this blade, I don't want to do anything but pick up a clean comb and a clean cutter, put them on my assembly jig, and put it together. I don't want to have to microfiber. I don't want to have to worry about grit, none of that. I don't want to have to worry about spring tension either. So I'm going to check my spring tension when I come apart. If you've got a gauge, you use it, whatever. This is going to be about 3 pounds, about where I want it to be. Maybe a little more than 3 pounds. If I'm not 3 pounds or better, I'm going to take this spring off of here. I'm going to go out to my truck on my bike. I think I've showed quite a few of you how I set spring tension. We'll do some one-on-one out there later if you guys need a little more. But we're going to go ahead and get a spring tension there as well, because we can always remove spring tension without taking the blade apart. The only way to add spring tension is to take it, well, the only way to add spring tension without altering the lever of the spring is to take it apart. If you're squashing the saddles at the back, no. If you're using the twist tool, that's fine as long as you get the same twist on both sides, because if you alter the shape of the spring in any manner, you're going to end up with more spring tension on one quarter than the other, period. Unless you do it exactly the same on both sides. And the only way I know to do that is to remove the spring and take it out and set it up and do it in one solid motion and put all of the extra spring tension in the arms of the lever of the spring, rather than in the saddle or bending it to where the guide pushes straight down and gives you more spring tension. So anyway, to take it apart here.
You guys can pull the cutter out. If you change the position while it's assembled, you can pull the cutter out and look at the guide and make sure it's even. That's the only. You can't do it while John's right. You can't do it while the cutter's in there.
All right, let's get it apart. All right, take it apart, and at this point, this is when I'm going to be doing any kind of cleaning I'm going to do. If you've got an ultrasonic sound, whatever it is, cleaner, you're going to do that. I don't mess with anything wet because I just don't have time for it. If I've got blade plaque, I'll get a wire brush out. If I need to add a little bit of fluid, I'll use an H42 or some Simple Green or whatever. But we're just going to get it clean. Make sure you've got nothing in between the teeth. Microfiber, and this is ready to go to be sharpened now, right?
Do you microfiber every blade before you sharpen them?
Yeah, I can try to get all the grit and anything that's on them off.
Before you sharpen?
Before, yeah, before. I'll show you guys my magnet up close if you want to see it out in the truck, but my little L-shaped magnet here is what I do 90% of my cutters on. When you set up, if you set the back of it off like that, it'll basically self-center if you just do that number right there. It's going to set those magnets up right in the middle of the synapse between the front and rear rail. See what I'm saying? So it kind of sets itself up. On the cutter side, Dennis Brooks' Acorn, this is my go-to on every single cutter out there, all the way down to the 5-in-1 cutters. This is what I use. I've got a bigger L-shaped magnet for some of the 3 3/4 or 5/8 blades to help with a little bit better grip. And if that's not good enough, I've got a boat anchor magnet that, yeah, it'll pick up a boat anchor, bad boy. Anyway, all right. Why does the shot machine work? When you put a blade on a shot machine, why do you have 100% zero failure rate when you're putting a blade on a shot machine?
Because it keeps it square.
You're keeping the blade this way square, you're keeping it flush, those arms do it for you. The only way to reproduce that and get a 100% zero failure clipper blade every single time is to do what that thing is doing. By hand, you can't do it. You know, I mean, most of the time you can. Even with the guide system, I'm going to say on a run of 12 blades, Nah, 12 blades is not enough. Let's say a 24 blade batch, I'm gonna have one failure out of 24 blades, you know? Even using the guide. And the only way to get this perfect hollow, the hollow doesn't move. The hollow's gonna stay on that radius no matter what. Where you put the blade in relation to where the hollow is gonna populate, that's it. There is no give. There is no nothing. The more accurately you stay in between the front and the rear snaps on that radius in even pressure, it's the only way to get a perfect cut, a perfect blade, a perfect hollow. That's it. So that's why you've got visual aid. And if I'm doing this without a guide, I've got control of this thing from my wrist, my elbow, my shoulder. I've got all this mechanics in place. Whereas if I'm using a guide, it's literally, I'm setting the palm of my hand and it's just my fingers that are doing the work. So I'm taking a whole lot of human error out of it at that point. I've got a visual aid so I can see that I'm staying square to the radius. And then from the rest of that is just feel, right? The second portion of it that I see people have problems with is how they actually address the plate. When you address the plate, I'm always coming down with the back of the blade first. Now you don't want to grind the back of the blade, but you want to feel it hit from the back of the blade first and then get flush. When they say you've got the touch, what you're actually feeling, the touch is, you're feeling flush to the plate. The plate is pushing, which is going to want to make it, when you feel that flush, you'll feel it. It's just that simple, and the only way to do it is to get on the plate and feel it, which we can do out in the truck. But anyway, secondly, we're going to look at our spark pattern. When I first set this thing down, it's going to be sparking from the corners out here on the inside of the plate because it's digging the hollow out here. As we come out of the plate, you'll see it migrate and start making that spark pattern more flush all the way across the front. As well, where you finish, there's a I think James Hammond calls it a sweet spot. Mm-hmm. Every plate has a different one, and all the sweet spot is the place where you're going to get the proper amount of hollow. It's supposed to be like 0.56 or 0.58 micron hollow, I think is what perfect is. You can get more than that on the plate that's made for a 0.56 or a 0.58 hollow if you finish further on the inside. So I'm normally finishing about middle of the plate, and the way that I gauge that is my grub block. Like I said, the hollow doesn't move. It's going to be where it's going to be. The blade has to find it. So you've got to find out where that stopping point is, right? When you're watching your spark pattern and you're actually doing the sharpening, 2 or 3 passes, as soon as your spark pattern is flush, it's ready to pull off. Same thing when you're pulling off, you want to pull front first. You don't want these teeth, you want to pull level and pull off, front first, so that you know you're not taking any more material off the tips of the teeth, right? And the more accurately you can address and remove and do your whole radius work, that's where your consistency comes in as far as 0 failures, right? So let's just go ahead and do it. Quick process, we'll set down. Watch my spark come in. We have a nice full spark pattern now. I'm going to stop and pull. I'm pulling just about middle or to the outside of the middle. If there's going to be something, I'm going to finish closer to the outside of the wheel for a safety. I want more flat than I want hollow. If I know I have a hollow, it's going to expel hair. It's going to help it. It's going to do its job, right? If it's only a 0.46 hollow. So I'm going to err to the caution side of flat. Because if I err to the side of hollow, my hollow may be populated wide enough and big enough to where it won't cut in the middle. So always err to the outside of whatever the sweet spot is. And the way you find the sweet spot is to rub blocking some time. That simple. Next thing we're going to do is we're going to read flash, and here's something going to be real easy. I'll go ahead and pass this one around. It looks great, man. The striations of the grit pattern, they're all straight, all in the same direction, and they all end at the very tips of the teeth. We've got big points on every tooth. I know that we've removed the right amount of material. The only thing we can do further to test this would be get on a rub block and see what the rub pattern is. I'm not going through that in this live.
How do you know you removed enough metal?
Just because my flash reads good, I have no damage. I've taken as little off as possible. You know what I mean? And I see that my scratch pattern is going again.
So if you make one half a pass and you look at it and everything's even, that's enough.
Let it go. Because that scratch pattern, reading flash, if there's no damage and it's all the same striations, you created a new, complete surface. If it only takes and that's it, that's all it takes. Anything more material-wise that we pull off, we're taking material off that's going to be better for another sharpening.
Is there any way you would know to do it 1 or 2 passes
No,
On your visual inspection before you start.
kind of, sort of, because if I pull it apart and look down there and it's like, the cutter's sunk down in there, I know it's going to come out in 3 passes. I'm going to make 5 or 6. I'll gauge how many times I go by what I see as we're taking it apart.
And that's gonna
Right.
be experience.
Right, that, and if I know I did those blades last time, it's already been on my plate, that is it's going to match it, right? Pass that around, let everybody see what that looks
How
like.
do you deal with a blade that's really dull?
What's that?
A blade that's really dull.
How do I know, or what do I do?
If you get a blade that's like super dull, you can tell it's been burned. Do you do more passes?
Yes.
Even
Just do
though
it.
don't-
It's just
even
like-
though it don't need it?
What's that?
Even though it needs it?
I can remember
The
not
blade
to.
is like really low now and you see it, you make one pass and look at it.
If the mechanical damage is gone, that's all we can do. We can't take out there, we can't put heat stamper back in.
How do you know how much radius right into the
How much what now?
radius on the edge?
It's,
The radius on the edge.
the radius
Especially
of
they talk
the,
on the,
you're speaking what, Greek to me, I don't know where you're seeing the radius at.
Radius of the blade is dull.
Oh, okay.
And I'm saying this because I disagree with what you're saying. If you make one pass and right at it here,
Okay.
the blade gets dull between the teeth.
Oh, okay, I
Where this surface and this surface meet is dull.
right.
And I'm just saying, hey, you guys,
This is important, actually, yeah.
so what happens is where this take this out, and I'm sorry, I
No,
don't
go
want to
ahead,
jump
this
in
is,
on your
this is
stuff.
great, this is, yeah.
Where this surface and this surface meet, that's a square corner. That's like the paper we're cutting, right? If the blade is dull, then that means where this surface and the surface between the two meet, that means that's round. And the way I teach is the blade has to be completely sharp. So if, no offense, no offense, if you only make one pass and you look at it, I can make one pass on the blade, look at it, it'll look perfect, put it on the rub pattern, it'll be perfect. But it may not have gotten rid of all of that radius. Sorry, Sean.
Okay, so in the way that I'm gonna deal with that is, I'm gonna be looking at that, I'm reading the flash on that like you are right now, and the shape of those teeth, I see that my gray, or my grain pattern goes all the way up, and the teeth are all, you can see a bird at the back of that, back there, and there's a bird that goes all the way up. And if you wanna go until you see a bird all the way to the tips, great, but I think you're going,
I don't think you'll see it at the tips.
yeah, I think
I've
you
never
take off
had
the
that.
material, you know what I mean? 1 or 2 strokes is not normally gonna do it, guys, you know what I mean? It's gonna be 3, 4 passes, maybe 5 passes, but there is the possibility, if you take off too little, that you're gonna do what he's saying. In between the teeth where the flat comes up in between the teeth, to the side, there is a little bit of roll, that's possible, but, you know, I think once you see a bird develop at the back and you've got a good scratch pattern, I feel like you're good. You wanna add an extra pass or 2, you're not gonna hurt anything, but remove as little material as possible.
Can you see the birds you're sharpening in?
You can't see anything, you just sharpen it up with a spark pattern.
Okay.
Right.
Hey, Sean.
Yeah.
For me, I think the answer is in look at it.
Yeah.
When I'm looking at it, I don't know, maybe for me, I'm more progressive. I'm looking at it under magnification.
Where's that blade, that other blade at that? Y'all still got it? Okay.
The look at part for me, to answer the question, is I'm looking at it under magnification. Individually, because blades are case by case basis. I'm gonna be especially looking at it on a highly worn blade. Under magnification, I can see that.
And I've got the microscope out in the truck, we'll look
I
at
don't
that.
think, for me, it's not a microscope. You can do that.
Yeah.
I just like a Hastings triplet lens. It's about 10 power. Gives you a wide view. I'm just looking.
Every single blade.
Almost. It's experience though too.
And the way I do it is simple. I take off between 1 and 2 thousandths on every blade. I personally don't have time to look at every.
Yeah, I
We're
wouldn't
using
use
the
that.
Traco a lot though, aren't you?
Huh?
We're using the Traco a lot though, right?
No, Nebraska,
Oh, okay.
Prego, and Shop.
Okay.
Actually, I got
All of
nose
them.
and screen cut.
Okay.
And it doesn't matter what you use. It doesn't matter what machine you use. Remove the metal, get a correct
Well,
copy.
there used to be the deal where you make a pass and then you get on that deal there and see that you removed it however many thousandths, right?
You can do that.
Yeah, and that's another way to do it too.
I
Yeah.
guess the blade reading, I'm reading the blade for the analysis. all this is happening really quick.
He's just saying, look at
And then,
kind of the same thing.
in final test, this whole year's experience with
He was
those,
saying
how
if you
long
want
the
to do
blade
it,
will
check.
last.
Oh, okay. And actually check.
Yeah, this is,
And that's fine too. If you want
this
to do
is a
that.
gauge, if you guys don't have one, and I'm just saying this, get a routine down. No doubt Sean's got his routine down, he can tell. If you're not sure, measure your blade before you start, sharpen it, and of course, the blade on the very first blade of the charge is gonna be remove more metal.
Yeah.
As compared to the last. So maybe on the first,
That's gonna take guesswork out of it.
yeah. Get it to where you're taking off between 1 or 2 thousandths consistently and get a regime down. On a Nebraska, I use a stream cut mostly, but stream cut is the same as a Nebraska. On the Nebraska, usually between 4 and 7 passes I can do it. Maybe the first 2 blades, I might only make 3 passes and have enough metal removal. If I'm down to like my 6th or 8th blade of the charge, I may make 6 or 7 passes.
Sure.
But then you just want to make sure. I see so many people, I see so many guys just do like that and look at it and be like, that's good. You don't even know if you got enough metal removal. And I'm not saying you have to check every one.
Yeah, I don't check everyone in the magnification. It comes with time.
It's like hollow grind. If I hand sharpen 10 blades and I check the hollow grind on all of them and they're good, I would say I could probably let the 11th one go.
Right.
And I know you can too.
Sure.
Yeah.
Sure.
All right.
That's the way to do it scientifically, to know that you've removed enough material.
Yeah,
Looking at it,
Exactly.
that's it, yeah. And that's probably, other than being a little bit time consuming, you probably ought to check every one for a while. too.
Oh, I
You
thought
get a
that was your,
routine.
I thought that was your rub block. I'm thinking, I've never seen a square rub block.
Yeah, right. All right, let's sharpen this other half. Same thing, middle of the snaps. We're gonna set down back first. We're just make the bigger passes and watch our spark pattern. We're gonna set down, damage out on the edge. And I believe, fucking lighting sucks, man. That's good, but I see no shining metal at the tips, and they'll be more apparent when we get out there on the under magnification. We'll really look at the tip, but in here in the light, best I can tell, we're good to go on that one as well. Pass that around.
Sean,
And
where
then we'll
did
clean
you
it up
line
and
up
get
the laser on that cutter?
it. Sir,
Where did you line the laser?
same thing in the middle of the snap, basically where the guide is.
In the guide?
Pretty much the guide. I mean, I know the guides aren't set one way or the other.
I think it's just
But-
at the back of the gun.
Yeah.
That's what I do too. Not that you need my approval, but
No, I get you.
I'm just curious.
You want to keep the magnet? No, I don't need it. The cone's coming around and we'll attach that in there and I think it'll make it. Where did you say you set that on? Same thing. I'm finishing the front rail, right in the middle of the snap and it's fucking rail. That's how I'm gonna make this, get in the middle of that. Yeah, okay, let's go back over to the laser situation real quick, guys. I want to pound this in your head. The hollow lives there, period, right? You want an even hollow on in between the front and the rear rail. There should never be a question about where the blade should be on the plate. It should be in between the front and the rear rail on the radius laser. Because you're wanting, that's not going to move. That hollow pattern that you're seeking is right there on that radius. And you want it in the middle of the front and the rear rail. Always. Always. You know? So anyway, I think that covers that. And we'll give these guys a minute to pass that around and then we'll get to reassembling.
What is
Okay,
what is the taper on the Nebraska?
I believe it's 7,000 something, I think, per inch, I think.
This wheel is 8.
Sean, kind of looking over your shoulder.
What is it, a trade?
Seeing the spark pattern down here, there was a gap in the middle. So I'm assuming you looked at the spark pattern at the edge of the blade.
What I saw when I started on that cutter, it looked like the left-hand side of the blade wasn't populating good. And all I did was shift my finger just a little bit over to that direction and put a little bit until I see my spark pattern get good. Now, a lot of times I'm swapping, I look at it, and I thought I was pushing that side, and I looked, and the whole right-hand side of the blade, it's got a bunch of shinies up there to move my pressure. And I'm gonna go back, and all I'm looking for, it doesn't matter which way I move it or shift it, as long as I get it flush and it's all in the same spot, my hollow is gonna be where it's supposed to be.
Are you looking to put shinings on every tooth?
I want no shinings left. I want all fresh grind patterns. If there's any of that old shiny left, then I haven't gone far enough. Okay. Right? You don't want to put that.
Well, I've heard both ways, but If you have the shinies, they don't cut in my
If you got shinies, they won't cut.
Yeah.
Because you haven't removed the material and put a new burr on. All right, and then cleanup wise, because we did all the dander and this, that, and the other beforehand, it's going to literally be, I'm going to go across that and try to get any grit that's stuck in between the rails there. It'll congregate there, and then when we're doing this deal, I don't see any burr on this. A little bit of a hook burr at the very back. I'm going to push that burr away from the cutting surface, and then I'm going to push that burr towards the cutting surface. Some guys use a brass brush on this. I think a nylon, you see I've been using this thing a while. I think this is plenty good, you know. And push the burr to the inside, that way when we assemble this and the cutter comes across, it's going to cut off any burr that may be remaining, right? And then we're going to go to...
process too, or just,
What's that?
you go through an actual wet washing process?
I don't do any wet washing, no.
Here you go, Sean.
What's that? Okay.
Looks great.
All right. You guys want to see the cutter too? You guys want to see this too? You seen that?
I do. And actually,
All right, okay. It's really not that hard, is it? It's really not that, you know.
What about demagnetism?
All right, same thing. I'm going to go away from the cutting surface. I'm going to push everything back in towards the cutting surface. I'm going to do the back side too. Kind of doesn't matter, but it gets the burr as well. And then pull. I'm trying to pull any bit of burr that's on there, and then any grit that may be there. And then we've got two blades that are clean. I need a guide. Somebody want to run up to the truck and grab me a guide real quick? Anybody? Want to make a run up to my truck? Just grab me a blue guide. It's in the little containers there.
I'd have volunteered, but running's not in my vocabulary.
Nah, I hear you.
If you see me running, you should run too. It's not too big.
All right, you guys that don't have one of these jigs, which is I think pretty much everybody or a lot of people here, I bought this jig because I was assembling these blades by hand. Right?
Quiet, please.
I bought this jig because I was assembling these blades by hand, okay? And the main step that was getting me was, I drop the spring on there, get everything lined up where I want it, I pick it up, and I'm gonna take my middle finger, I'm gonna put it in the middle of the saddle to hold that saddle in place, and I'm gonna put my fingers like this to hold the blade and flip it over and look. I'm only moving just my middle finger in here to line that socket up to get the hole lined up, right? And I'm doing that, and man, these two knuckles swole together. They look like one single piece, basically. And it got to the point where my hand was literally, I was walking around like this, I was crippled looking, you know, it's terrible. I went in and seen a hand doctor, and he thought, I'd laid my hand right on the table, and I could not straighten my hand out. I don't remember what it's called, something.
Dupuytren's.
Yeah,
I've got
Dupuytren's
it.
contracture. Dupuytren's contracture.
Got it.
Right.
Talk to me.
And it's hereditary, right? So what I've done to it, mine was just damage, but it was the same kind of situation. I went to this machine because I don't have to do that one action anymore, and 2-3 months in, my hand's great. You know, these things are kind of expensive, $500 to $80 through the shop. I think it's worth every penny. You're going to be a little bit slower on assembly at first, but once you figure out how to do it, and you know that you're going to have to set your cutter back a little bit further and this, that, and the other, once you get all the little in place, I think you're just as fast using one of these as you are by hand. I am. I truly believe I am. Anyway, all right. Go together here. There's nothing scientific about this portion of it. It's just oil across the front, a little stripe, a little dot in the back on each corner. And we'll set our cutter in place.
Okay, can we stop and talk?
Sure.
Whether it's assembly by hand or on this machine?
Okay.
What is the placement of the cutter?
Basically, I'm going to want, no matter what blade I'm doing, unless I'm talking a 40 or a 50 blade, I don't know as far as a micrometer, but basically, when I get it together, the setback that I'm going to want is about a dime, the width of a dime.
Okay.
That's what I'm looking at. I want to see the naked, you know, fresh, a dime all the way across there on the cone. Is what I'm looking for when I get together. On your 40-50s, you want to go as close as you can to zero gap. You want to make sure your cone's not, or your cutter's not hanging because you're going to cut an ear off.
Yeah.
Right? But go closer to zero gap on those because those are for surgical purposes, being able to get all the way down to the skin.
Okay.
That's about 30 thousandths on the coarse blades.
Right.
And I think it's like 15 thousandths on the 40s and 50s.
You don't oil or anything between the guide and the...
He just dropped oiled it.
Yeah,
Put
he did.
dots on there.
Put a drop on
No,
there.
not between the blades, between the guide and the cutter.
Yeah, I just put a drop on there. I set it down. I did that dot, and then a dot on top of the cutter, and you're good to go. The new blade guides that we've got that Cody's using, these here, you can actually see the little divot in the middle there. It's got two tips on each end of it. So when you put a drop on that, It actually sucks down into that steel there. It's a positive function on these steel here. I just don't know what the longevity is gonna be. I've only got about 60 of these out there in the field right now.
I didn't, so how did you determine whether the spring is correct?
As far as,
Like here's the spring, as far as both sides pushing down even?
just a good fresh spring. I mean, you know.
I mean, do you check that?
The only way I know to do it is to push the cutter to one side and do the gauge and see how much pressure it takes on that and push it out to that side and see, I mean.
Can I show you how to do
Sure,
mine?
go ahead.
Yeah.
So-
We would love that.
Mow is better.
I'll make this one off. So here's what I'm saying, here's the spring,
Push it.
so it's like this, right? So, you mind, come on?
Go ahead.
So whenever I assemble it, can you take that back out? And then I got the screw, you don't have to screw.
Magnet is pulled off. Yep.
So whenever oh dang it.
You throw it on the floor, okay.
Yeah, makes sense.
I've done that.
This is what I call checking for offset springs. Sorry.
Good.
And then of course the blade guide's gonna be on it. So I set it on here like this, right here, okay? Push right here, and push right here. See that raising? See this raising right here, guys? Mm-hmm. And then when I push on this side, watch this. When I push on this side, it won't raise. See that?
So it's got a little twist in
So
it.
when you push this and this side comes up, take and push that side down. And you can see,
You can see it's uneven, yeah.
yeah. I mean, that's just how I do it.
Sure. And you know, it'll also manifest as you're putting this thing together, when you get your cone cutter on there, straight.
Sorry, Sean.
No, it's all right, man, it's great.
That's what, hey, that's what this is here for.
Yeah.
It's everybody sharing and learning together and growing
Exactly.
together.
Absolutely. I'm setting it up to where I want it. I think it's perfect, right? And then when I sit down on there, if you've got a bent spring, another thing that's gonna happen that's gonna manifest is, when I start squeezing this down, wherever that cutter is on that cone, when I start squeezing the spring pinch down, you're gonna watch that cutter walk forward, right? And if it walks forward, right hand first, you got too much spring pinch, or more spring pinching on that side than you do on the left. The cutter's actually gonna shift because you're elongating that lever, you know what I mean? It's really bad on a wall comp or the 5-to-1 blades. You bend one of those springs board together, it will dance that thing sideways, man. Anyway, all right, so we'll get that down. Crooked as hell.
You don't worry about that mashing the socket too hard.
What's that?
You don't
It
worry.
will. It
Oh,
will.
you-
You just
okay.
get it down till you get it and it flushes. Once it flushes pretty good, then you're good. All you're doing is holding that together tight enough to be able to come off and get screws in it.
Is that for sale?
No,
Come on now.
There's nothing stock at the shop machine.
you don't ever have them in stock.
Ever. No, I've been looking for years.
And then we're gonna rock you forward.
I don't see them on eBay used either.
I'm jealous,
I
man.
got that one for 500 shipped.
I'm just glad I
Put it
got
on
to see one in
Sharpening,
person.
everybody
It's
has a
like,
chance at it, buddy.
it's like the elusive.
I was just the first one
I
to
wanted to
jump.
buy one at the last show and somebody bought it before I left.
Might be that one.
No, it was in Sacramento.
Oh.
All right.
Yeah. I don't need it, but it's cool. You know how sharpeners are. A lot of these guys
More
need
tools, more
stuff
tools.
This weekend they don't need, but.
All right,
cool.
now,
Look at Larry. He goes, yeah, guilty.
That's right.
I'm happy about my setback there. The other thing is, we never want one of these ears on the socket touching the spring. Don't want it. If you've got one that is touching, what I do is I go back to my flathead or my Phillips head screwdriver and just crack it loose. You know, 1/16 of a turn or so, where it will move a little bit. I'm gonna take a small flathead screwdriver and I'll put it right back here and push that back. And I barely split it to where I know I don't have any contact between my spring and my socket. I'll tighten it back down. Now, one step that I missed on disassembly, before you take the blade apart, I think the proper time to do it is to set your socket. The one that I've got, that I made myself, doesn't have a set screw in it. So I just kind of get it where it's flush. The one that Dennis sells, it's already set up for an ended socket. So when you put it down there, you're just going to squeeze the ears in. And it didn't hardly even move because it's pretty close to where. If I had mine on there, it would have squished it in until it, you know, it looked funky, which we don't want to do. Tension wise, I think we're about real close to 3 pounds. Let's just check.
Were you just bending that spring or the ears on that, when you took that flat head?
Just here, all I'm doing is loosening those up. I'm setting that flathead right there.
Oh, so you pull the spring?
I'm just pushing, making sure the spring is just split off where those not touching.
I see.
That's it.
Yeah.
Yeah.
What happens if the spring's touching?
You'll get a vibration because that spring does wobble and winky around a little bit, right? And it'll make a noise.
So this will
The,
calm
the
down
socket
the blade
is
a little
static,
bit,
it's
quiet
not
it down.
moving. What's that?
So it'll quiet the blade a little bit.
It'll
right?
quiet down a little bit, yeah.
Yeah, your groomers are going, it makes noise.
So do you.
Let me see where this thing is sitting.
What a coincidence.
And we are setting about 2 3/4 of a pound on the gauge there. I'm gonna try it there. If you can get it, I like to have 3 pounds as a static pressure. But if it's 2 3/4 or so, I'm gonna test cut it and see if it flies. If it does, I'll probably send it out the door. But 3 pounds is gonna be my guarantee against them getting up into a mat or something. If you've got 3 pounds, 3 1/4, you know it's gonna cut through anything depth-wise.
What happens if, I know the answer, so.
Go ahead.
But what happens if or, let me say it this way. If your spring tension, that way I'm not putting you on.
Good.
If your spring tension's too loose, say 2.5, and it passes your test cut, right? You know, maybe your 1 inch cut you got here, or the string. If your tension is too loose, what'll happen is a lot of times the customer will say, it cuts good for about a minute or 2, and then it jams up. And then I clean it, and then it cuts good and it jams up. So if that happens, it's probably because it's
Spring tension, yeah.
Too
And a
loose.
lot-
Too
lot-
loose.
A lot of times what I see too is a different hair coats. You know, this stuff's real nice and thin and wispy. They get onto a terrier or something and it doesn't want to, it's going to start pushing hair. I try to shoot for 3 pounds, you know. But like I say, if it's a 2 3/4, 2 7/8, whatever, I'm not going to fuss about it, you know. But anyway, we're going to go back in. We're cutting good. The thing that's going to happen when you're when you don't have enough spring tension is you're going to be able to go right through the wispies, no problem. And then when you get down and you start digging into the coat, that's when it's not going to want to cut. This is going to go through nap. I mean anything. I'm getting jute there is what I'm getting, but it's going to go through just anything there. Good even cut. That's all we're looking for, man. And then from that point, it's blow it off with high velocity air, and it's ready to go in the bag. I oil it before I put it, or as I'm putting it in the bag, and it's ready to go back to the customer at that point.
May I see that?
Yeah. And then rinse and repeat, right?
Now, Sean, I didn't, maybe it's passed over. So you just sharpened the blade and they got grit on it. What do you do next?
I didn't demag either. I didn't demag it in that. I'm always going to demag and high velocity air and use a microfiber before it goes into back.
No, you don't dip?
I don't dip anything, no. I know that's the method you use with mineral spirits, right? You dip the whole thing and then blow it out, I guess. Any step you add, what's
Don't
that?
blow it.
Oh, okay. Any step you add that's going to add cleanliness or whatever to it, you're not hurting yourself. It doesn't slow you down a bunch, right?
Just swish and flick.
Yeah. When I come off the plate after my disassembly, literally, I'm going to brush it off, hit it with some high volume or high velocity air, and then I'm going to use a microfiber and clean it up, and I'm done. I'm going to bag oil it. If you want to add the dip it in liquid to help maybe get some grit that's in between somewhere, that's a possibility too.
Do you notice, and I know
Go
this
ahead.
too. I noticed that the 5/8, 3.5, 3 3/4. I noticed those blades almost are the main ones that have the most dander.
Yeah.
Are you the same?
As far as damage from use?
No, dander.
Oh, dander. Oh, yeah, because the dander is going to be in between. That's where you're in between.
Yes.
The more surface area you have in between those teeth, the more damage
That
or
white,
dander
it's
you're
that
going to
white
have.
stuff.
Yeah. Yeah, if you got a 5/8 or a 4, you know, or a whatever, you're going to really want to get in between those teeth real good to get all the dander out of there.
5 all the way up to the 5/8.
Yeah.
You know, we started just using, and all my sharpening is in my shop, so I got a little bit more room than you guys. But, we just started using an ultrasonic cleaner on the big blades, and it's just a little extra step, but oh my! And if you guys want to do this for your groomers, show them. Get some clean soap. Get a blade that's got a lot of dander on it. Drop it in there, and while they're watching you, you will see just the gunk just float up, just like that.
It's nasty, yeah.
Yeah, so it's just a way of impressing your groomers.
Soapy water being like
I
dish
knew,
soap, or like soapy water being like dish soap, or
Simple green
okay.
is what we usually use.
Yeah,
I
Diluted.
Now listen, I don't really suggest using any water-based solution to the groomer.
Yeah.
Because
Rust.
unless they're really diligent about cleaning the moisture off the blades.
They're not.
They're not. So I would go
They
with
don't
an
oil,
H.
you're gonna get water.
So I would go with an H, like an
Now you
H.
can check in between every
Oh,
teeth and know
okay.
that you know.
Harbor Freight,
all
just
this
at
is still
least
a
a
different
6 liter